Course 1 Math Lesson 6 is called Fractional Parts. When you were younger, you learned counting numbers, maybe whole numbers, possibly integers if you were advanced, but took a little time in your education career to learn about how things aren't always as simple as full one whole number. It could be part of a number, it could be a third, it could be a fifth, it could be 7/8, it could be a lot of things. And so you learned that this doesn't just mean a bunch of lines in a circle. It's 1/6. Blue is the 1, number of total parts, the 6. You put 1 over 6 like this. But today our focus is not to be able to say, well, that looks like 1/6. Our goal is to be able to take 1/6 then and apply it to a larger group of numbers. Or maybe say, what's 1/3 of 6? So not just saying, what's 1/6 of 6? Or anything like that, but or just what does 1/6 look like in a pie? We want to say 1/6 of a big group. For example, I have all these people here. Let's say I don't know, it looks like maybe 200 people. Let's say there's 200 people in a crowd, and if we know how many people there are, how can we find out what's a sixth of those people? Maybe a word problem could say 1/6 of the people didn't like spinach. How many people is that if there's 200 total people? A couple ways to understand each of these numbers. Remember, review, the top number is the numerator. The numerator. I'll put a fraction bar here in red. And the bottom, a denominator. And there's ways to understand that. Usually when you're showing like a circle and you want to show sixths, that was a bad example. Let's just use the book. That's why it's here. Back. 1/6 looked like that, right? Okay. Shaded is that top number. It's the number we're talking about. So another way to understand that is the number being described or discussed. Okay. The shaded number is this black one up here. It's the top. Okay. Top is your shaded. And the bottom is the total number of equal parts in that whole. So bottom is total number of all the parts. Okay? With that information, how could we solve this? Let's divide the 200 into 6 equal parts. Okay? 6 into 2, no, but 6 into 20, 18. Again. And that's as far as we can go. Remainder 2. You can't have a remainder when you're counting full-sized people. So we'll stick with 33 on the bottom. And on the top is the number being described. If 33 is our total number of sixths, then we want to multiply that by the number of sixths we want. So how many sixths? 30. We just want the 1. So this isn't a denominator or numerator. This is describing how many, and then we multiply by how many sixths we want, which is just 1. So roughly, because there was a remainder, it's rough, but 33 people would make up 1/6 of this group. You divide into equal number of how many you'd like, and then you multiply by how many of those groups you want. Let's maybe try it with simpler numbers. What if we had a sixth of 200? No, we just did that. What if we had a sixth of about 2/3 instead of, oh, I don't know, 36? Simpler numbers, even numbers. What do we do first? Divide your 36 into our denominator, number of equal parts. That's going to come to 12. Ignore this now. So 12 is in each group counting up to 36, which makes sense. There's 12 in here, 12 in here, and 12 in here, and that adds up to 36. 3 total groups of 12. Even groups. I like it better now. Now we want to know how many is 2/3. Well, shade in 2 of these and add that number up. 12 plus 12 is 24. So 24 is 2/3 of 36. Now, if you haven't noticed already, all we've been doing is taking this fraction and really multiplying it by the second number, which means we will multiply this and then divide by this. It's the other order, but because we've learned those operations, multiply, divide, are commutative with each other, it's not going to affect the final answer. If I multiply 2 by 36, I get a big number, 72, but I can divide 72 by 3. I'm getting messy, I know, but you figure that out. 12. Sorry, this should have been a 2. You get 24, which is the same. If I had, I don't know, let's say 40 pieces of pizza inside of here, 40 total, and I wanted to describe 3/4 of 40, so there's a lot more slices in here, and I want to know how many slices would there be if there were 40 total, and I had this much. How many would be in here if there were 40 total? So 3/4 of 40. You could either understand that as well, let's divide 40 into 4 groups and multiply how many are in each of those then by 3, the way we started doing all of this. Or you could just go straight to 3/4 times 40 is 120 over 4, because we multiply through the top, and this is really over 1. And that's going to come out to 30 pieces. We could have done that the other way. 40 divided by 4, right? So there's 10 in each group, and then we multiply by how many are being described. 3 times 10 is 30. However you like that better. Let's apply it to a couple more from the book. They would like us to be able to say what number is a half of 450. What do? They say divide 450 into 2 equal parts, then find the amount in one of the parts. So 450 divided by 2 is 225. We only need 1/2, so we stick with 225. How about 1/3 divided into 3 parts, and that's just one part that we need, 150. 1/5, so it's easy when your numerator is 1, because then we're just dividing by the denominator and calling it our answer. Okay? You can copy and shade 1/3. Remember, 1/3 of 6 is 2, because 1 times 6 is 6, divided by 3 is 2, so you just shade 2 parts to show 1/6, or 1/3 of 6 boxes. We're already ready to start putting things in our numerator, I feel. But let's do our best with these, keeping in mind how we do different things, and let's do all the practice.